Alright, this video is an introduction to Chapter 5, Section 3, Is it a function? So, in this lesson we finally get to this definition of a function and what it means when we're talking about functions. So, big goal here is to determine whether a relationship is a function based on its description, and that's what in this video I'm really going to focus on. Okay? So let's start with the definition of a function. So a function is a rule, any math rule, and we've been looking at many of those throughout the last couple days. So a function is a rule that assigns each element from the set of inputs. So what the heck does that mean? Each element from the set of inputs basically means each input. So each number, and it's not always a number, that's why it doesn't say number, it says each element, and I'll give you some examples. But each thing that can be an input to exactly one thing that can be an output, or each output. Okay, so let's just look at a really basic example. Let's say we got two tables here, and the question is, does each table represent a function? So if you go ahead and take a look at those two tables, and we're looking at the inputs, we're looking at the outputs, and we're checking, does each input have exactly one output? Okay, well, as I look at this first table, 0 to 12, okay, 3 to 15, 4, 16, 9, 21. Then I get down to this one, I say, hey, 3, wait a minute, I just used 3 up here, and 3 produced 15. Okay, whatever my rule is, and it doesn't matter what my rule is, but whatever my rule is, 3 produced 15, but then down here, I used 3 again, and that produced 36. So some people would say that's not a fair rule. It's not fair to say that if I give you the input of 3, and one time you give me 15, and another time you give me 36, I wouldn't be able to break that rule or figure out what rule you're using. Okay, so if I go over to the other table, let's say my partner here has a rule, and I'm giving inputs of 0, okay, returns 1, 3 returns 7, 4, 9, 9, 19. So then I go back and say, well, what was 3 again? Remind me. And they say 7. Here, each input had exactly only one output. 3 didn't change like it did in the first table. 3 is still produced 7 in both cases. Okay, so this one over here is not a function. This one over here is a function. Okay? Let's look at some other examples. We have basic examples like, and I'm going to write it such as this, 4x plus 1. Well, if I make an input and output table, and I use some inputs, for example, it doesn't matter how many times I put in this input of 0, 4 times 0 plus 1 is always going to be 1. Doesn't matter how I put it in or how many times I put it in, it's always 1. Just like 4 times 1 plus 1 is always going to be 5. It's not going to ever change. 4 times 2 plus 1, etc. So this function here, it is a function because each input only has one output. There's no other option. Alright, so let's look at another math example. Let's say f of x equals plus or minus x. Okay, so my input and my output, we'll do the same thing. Pick some inputs and plug them in. So 0, if I plug that in, is going to be positive or negative 0. Okay, well, you know that 0 is it's not positive or negative, so that doesn't have any options. But here, if I plug 1 in, 1 could be positive 1, or it could be negative 1, because of this rule that I made up. Said my input is going to be the positive or negative version of that input. Okay, well, that doesn't work already. And it's going to be the same down here. But it doesn't matter. As soon as I find one input that has more than one output, I know this is not a function. Doesn't work. Okay? Alright, let's take a look at another example. What if I did one of these graphs we just got done doing, absolute value of x. Okay, so let's do these for my inputs. Okay, absolute value, remember distance from 0, so it gets rid of the negative. Your answer is always non-negative. So -2 is 2 units from 0, -1 is 1, 0, 1, and 2. So the question is this a function? Well, does each input, and I want to label that as such, does each input have exactly one output? And if I look, -2 only produces 2. That's the only answer for 2. +2 only produces 2. Now, is there an output such as 2 that has multiple inputs that lead there? Yes, that is the case. But we don't care about how many different ways I get to a specific output. I just care that each input only has one output. So this here is definitely a function. Okay, again, it's all about, does each input have exactly one output? Doesn't matter about outputs and how many ways I got there. All right? Let's look at some examples where, some non-math examples of a function. Okay? So it doesn't always have to be math related, and that's why this definition here says each element, each thing that is an input. All right, so let's do this first one. Let's say my rule is my input is type of vehicle. It produces color it is made in. Okay, so that's kind of goofy, that idea there. Like just the idea that this is going to be a function or not. But think about this. If I'm using a function in a non-math setting, so let's say I am, I don't know, looking up a car online or trying to find cars for sale or something like that, and I say, hey, I'm going to type a vehicle in, and so I only want I want it to return just the color that it's made in. Okay, well, is that going to fit the definition of a function? It's definitely something maybe you could create a computer software to do, or an internet website can do. Type in, maybe I type in Chevy Impala. Now the output is, well, they make red Impalas, they make black Impalas, they make gray Impalas, I've seen blue Impalas, etc. This one car is made in numerous different colors. So Chevy Impala has numerous outputs. Okay, so this input does not have just one output. Type in a different vehicle, Chevy Silverado. Same thing, I've got all these different colors. So this isn't a function. It's something I could use to search. Again, there's applications of that, but it doesn't fit my definition of function. Okay? How about if we did, my rule was day of the year, and my output was average temperature that day. Okay, so if you've ever watched the weather, sometimes they'll say, hey, the average temperature for today, is average of 20 degrees. Today it's supposed to be below. What we would expect is the average is going to be 10 degrees. Okay, so we have historical data, and we're basing that off of, let's say, Waterloo, Iowa. Okay, so my input is February 7th. Okay, is there more than one average temperature for February 7th? The answer is no. You take all the previous years that we have record for February 7th in Waterloo, Iowa, add them all up, divide them how many you have, and your output is, you have one, and I don't know what it is. So you have one average temperature. There's only one output. Okay, I want to know February 8th. February 9th, etc. Okay, so these are my inputs. I could write the date as a number, but this is an element, February 7th, February 8th, February 9th. It's a thing that can be an input. My output is one specific temperature. Okay, so yes, this is a function. And I wrote that kind of sloppy, I apologize. Okay, so let's look at one more aspect of determining if something is a function or not. So let's go back to this example where I did the, let's look at this example right here. So if I was to graph this, I'll draw an x and y axis right here, and I'll just sketch a small little graph there. So x0, y1, x1, y5, x2, y9, etc. I've got this line that I'm forming. Okay. This one over here, on the left side, we said is not a function. X is 0, 0. Oh, let me grab a different color. 0, 0. 1, x1 could be 1, it could be negative 1. 2 could be 2, it could be negative 2, etc. So as I draw these graphs, it almost looks like the absolute value function, just turned sideways, and I've got this shape here. So almost like a sideways V, or you could even say it's a less than sign, almost like Pac-Man without the body. That works. Okay, so how do I look at their graph and tell if they're a function or not? All right, well, remember, we're talking only about the inputs. So if I kind of mark out where my inputs were, I want to know, does this input have more than one output? Well, at this point on the x-axis, as I go over, I see that I'm here on the graph. There's only one spot. This point here, again, there's only one spot, etc. So there's only one point on the graph that I can go to if I go to any of these points on the x-axis. So each input, each x value, has exactly one output or one y value. Over here, on this graph, I go to my inputs, and I see this input, remember it was 1, has an output here and here. So I can see, well, shoot, there's two outputs. This input, there's two spots on the graph that correspond with that point on the x-axis. So again, there's two outputs, etc. Okay, so we can see that over and over. As I move along the x-axis, there's two different locations on the graph that goes with. Alright, so how do we simplify that a little bit? This won't be directly done in 5.3. We're going to look at this a little bit more later, but it's a good time to introduce it. We're going to simplify this with this thing called the vertical line test. Okay, so I'm going to just draw a vertical line. And what I'm interested in is, does this vertical line test ever cross my graph more than once? Well, if I move my vertical line alongside this graph, so I'm finding a coordinate here on the x-axis that I'm interested in. So remember, the equation for a vertical line is x equals a number. It's essentially what I've done. It says, hey, when x equals 4, where does this vertical line cross the graph? Well, I see it crosses right there. So when x is 4, I have my output. When x is 2, my output, according to my table, should be 9. Okay, that's where it crosses the graph. So let's slide this test over to the other graph, and look at this. When x is 2, shoot, it crosses in two different spots. When x is 3, it crosses in two different spots. So if a vertical line would cross your graph more than once at any point, it's not a function. And this is a good example right here. Not a function. This one over here is a function. It never crosses this graph more than once. Okay? So that's again, an introduction to 5.3. Is it a function? You use this information in class while you're working on your activity, and we'll certainly follow up with more of that, but definitely enough information to get you started.